So in this lecture, we're starting a new unit. It's Unit 4, and we're talking about applications of derivatives. So where can you use derivatives to use it for something in the real world? As of right now, we just taught you all the steps to take derivatives, but now we're going to talk about how do you use them. So first of all, this standard 1, is about local maximums and minimums. Another way that people talk about, they call it relative as opposed to local, and they call it extrema, meaning extreme maximum or extreme minimum. So first of all, I want you to see these three graphs. These are examples of local maximums. In this first one, you'll notice that this is a maximum. Oops. You'll notice that this is a maximum here at this top point because it is the highest point, much higher than the ones next to it. Here, to the left of the maximum, you'll notice that the derivative is positive. At the maximum, the slope is 0, and after the 0, the slope is negative. On the second graph, you'll see that the maximum is here. You notice again that the slope is positive. Then it hits, you see it's kind of like a sharp corner. This is actually a slope that does not exist. And then after the sharp corner, the slope is negative. And the last one, again, we have a sharp corner. So again, we have, and again, just by looking at it, you can tell this is a local maximum. We have a slope that goes positive, hits the sharp corner with a slope of does not exist, and then the slope becomes negative. Same thing goes for what they call relative minimums or local minimums. On these graphs, you'll notice that here, here, and here, the graphs have a local minimum, meaning it is the lowest point compared to the ones next to it. This is kind of the reverse of what I just showed you before, but prior to this local min, I have a slope. The slope before it goes into that local minimum, it's negative. Then the slope is 0. Then the slope goes back to positive. On this one, the slope is negative, and then the slope becomes does not exist because I have a sharp corner, and then the slope is positive. And the last one, even though it's looks kind of similar, again, the slope is negative, then you get a sharp corner, which means the slope doesn't exist, and then the slope becomes positive. So what are we going to use this for? Basically, what we're going to do is we notice that to find the maximum or minimum, it's where anywhere the slope is 0 or undefined. So I can work backwards. If I don't know how the graph looks like, I could find where the derivative of the slope is 0 and find out where the maximum or minimum of a function is. So let's do it step by step. First of all, let's find what they call the critical number. The critical number are x values where the derivative is 0 or undefined, and these are the places where you could have a local minimum or maximum. There can never be a local minimum or maximum where the slope is anything else. If the slope is 0 or the slope is undefined, you have to have a local max or a local min. Okay? So first of all, step 1, let's see if we could find the critical numbers. Again, these critical numbers will tell us where the maximum or minimum is. So in this very first problem, I have this function. So what I'm going to do is I'm going to take the derivative. I get 4x to the third plus 12x squared plus 8x. So this is the derivative function. And again, I want to know what the critical number is. I want to know where the max and min is. So remember, the slope has to equal 0 or it does not exist. So for the most part, unless you have a fraction, you're always going to set this to 0, set the derivative to 0, and solve for the critical number. Sorry, this should be an x squared. And solve for the critical number. In this particular problem, I could factor out a 4x from all of them, like so. Again, x squared plus 3x plus 2. This becomes 4x, x plus 2, x plus 1. And here are my critical numbers. And again, since I have 3 things that equal 0, one of these has to be equal to 0. So x can either be 0, x could be negative 2, or x can be negative 1. I found the 3 possible places where there can be a relative max or a relative min. This next one looks like a little bit more difficult, and it is, but you should feel comfortable doing these also. Again, if I want to find the critical number, I'm going to take the derivative. And in this particular problem, I have one thing multiplied by another thing, so I'm going to use product rule. The derivative of the first one, which is half x to the negative half, leave the second one alone. Okay, so all I did is product rule. Plus, leave the first one alone. And the derivative of the second one, you notice that the derivative of the second one is a chain rule problem. So I'm going to do the derivative of the outside, which is going to be 4. Let me minimize this. 4 parentheses 2x minus 4 to the third power. Again, by chain rule, I did the derivative of the outside times the derivative of the inside, and the inside function derivative is just 2. So there's my chain rule, my product rule, and I'm going to simplify this. I'm going to get, in this particular case, I'm going to simplify this to 1 over 2 radical x, because this x to negative, this x to negative half means a square root of x, but in the denominator, and I have a 2 on the bottom. And then I have I'm going to delete this 1 real quick, but I have a 2x minus 4 to the 4th power, and I'll put that here on the top. Plus, here you'll see I have a 4 and a, Here you see I have a 4 and a 2, so I'm just going to move that in front. So I'm going to get a plus 8 radical x, parentheses 2x minus 4 to the 3rd power. Okay, a little bit confusing, but watch this. First of all, I noticed that in both terms, again, I have term 1, and term 2. This is term 1 and this is term 2. You'll notice that I could factor out, they both have 2x minus 4 to the 3rd power. So I'm going to factor that out. I'm going to get 2x minus 4 to the 3rd power, which leaves me, again, factoring out, I'm going to get a 1 over 2 radical x in the first term, and I'm going to get an 8 radical x in the other term. And again, because I'm trying to find the critical number, or trying to find out where this is, the maximum and the minimums are, I'm going to set this equal to 0. So like I did for the last problem, either this has to equal 0, or this has to equal 0. This one on the left, the 2x minus 4 to the 3rd, what would make that 0 is 2. So I have a critical number at x equals 2. On the right one's a little bit confusing. It's like, what can I do to make this 0? There really isn't anything that would make this 0, but I do notice that if I put a 0 here, wouldn't that give me a 0 in the denominator? Remember, 0 in the denominator is undefined. So this, what would make this one 0, quote unquote 0, or would make this undefined, is x equals 0. So my two critical numbers are 0 and 2. Again, that's a very complicated problem, but hopefully you understand what I'm talking about. Trying to find out what x would make the derivative 0 or undefined. Now, here's the big thing. It's called the first derivative test. This is how you could find out where an interval is increasing or it's decreasing. Okay? If you find out that the derivative is positive, okay, if you plug in a number and you get a positive number, that tells you that it's increasing. If you plug in a number, or if you get a, if you plug in a number and you get a negative number, let me make this more clear. If I plug in a number and I get a positive number, it tells you that f of x, the function, is increasing. If you plug in a number and the derivative is negative, that tells you that the original function is decreasing. Okay? And then you can use this to find out your local minimum. Okay? Like I showed you in the pictures beforehand, if you get a slope that goes positive to negative, and some people forget this, so I always draw it out. If I get a slope that's positive, then the slope is negative, you get a maximum. I'm just going to write max. Okay? If you have a function and it goes from negative, or derivative of the function, and it goes from negative to positive, again, I'll draw it if I forget. If I go from a slope that's negative, then a slope that's positive, I'm going to get a min. Okay, so this is all kind of leading up to, these are all like different steps. So the first step, I found the critical number, and then I'm going to show you how to apply the first derivative test to find out where is something increasing and decreasing. Okay, I'm just going to do two problems for you right now. Here's a function, and the question asks, where is this increasing and where is this decreasing? Find the coordinates of all the relative extrema, or find the critical numbers. And do I have a max or a min? Okay, all without a graph, without even looking at anything. Can I just tell by this function, what are the critical numbers? Where is it increasing and decreasing? Do I have a max or a min? So here's my first function. Let me zoom in real quick. And I start off, step 1, here I'll even number it for you, find the critical numbers. Well, we practiced this before. The derivative is f prime of x, and that becomes 4x to the 3rd minus 16x. Okay. Remember, I set this equal to 0 because I want to find out the critical numbers, and I will factor this. They both have a 4x, so I'll take out the 4x. This becomes x squared minus 4. Factoring even more, I get 4x, x plus 2, x minus 2. And again, find the critical numbers. I set this equal to 0. I have 3 things that are multiplied that give me 0. That means one of these has to equal 0. That means x equals 0, x equals negative 2, or x equals 2 would make this whole thing on the right side equal to 0. So I found my 3 critical numbers. Okay. Now, how do you do the first derivative test? This is what I do. You're going to make a number line, and on that number line, I'm going to put these critical numbers in order. So negative 2, 0, and 2. These numbers tell me that I have a max or a min at negative 2, 0, or 2. So at negative 2, 0, or 2, I have a max or a min. What that also means is that it switches positive to negative or negative to positive at those numbers. But I have no idea, do I get positive or negative? Do I get negative, positive? I have no idea. So what I'm going to do is I'm going to test some numbers in between these intervals, interval 1, 2, 3, and 4, plug it into the derivative and see if I get positive or negative. Okay. For the first interval, one good number to test is negative 3. In the second interval, I'm going to test negative 1. In the first interval, I'm going to test 1. And in the last interval, I'm going to test 3. I will plug all of these into my derivative to see if I get a positive or negative number. Okay, so how do I do that? Basically, I'm going to have to plug negative 3 into all 3 of these pieces. Piece 1, piece 2, and piece 3, and see what the sign is. I don't really care what number I get. I just care about what the sign is. Is it positive or negative? So what I'm going to do is at first, I'm going to start with negative 3. If I plug negative 3 into 4x, I will get a negative number. So I'm going to draw a little negative sign. If I plug negative 3 into x plus 2, I am also going to get a negative number. And if I plug negative 3 into x minus 2, I am also going to get a negative number. That tells me negative times a negative times a negative. The interval before negative 2 is all negative. Okay? I will now work with I'll now test negative 1. If I plug negative 1 into 4x, let me just draw that for you. Put negative 1 there, I'm going to get a negative number. If I plug negative 1 into x plus 2, I'm going to get a positive number. And if I plug in negative 1 into x minus 2, I'm going to get a negative number. Negative times positive times negative will give me a positive number. This tells me that between negative 2 and 0, it's positive, or it tells me that it's increasing. From 0 to 2, I said I'm going to test 1, so I'm going to show you how that looks like again. I'm going to take this and plug it into here. Now, if I plug in 1, I'm going to get a positive, and a negative. Positive times negative is a negative. Okay? So now I have found that the interval between 0 and 2 is negative, or it's decreasing. And the last thing I'm going to do is I'm going to test the number 3. When I test 3, again, to do this very quickly, I'm going to plug in 3 into 4x, I get positive. I plug in 3 into x plus 2, I get positive. I plug in 3 into x minus 2, I get positive. This whole interval after 2 is positive. So to answer the first question, which was where is this increasing and decreasing, I'm going to label these. First of all, it's decreasing from negative infinity to negative 2. And it's decreasing from 0 to 2, because that's where I have minus. Okay? It's increasing at negative 2 to 0 and 2 to infinity. That's how I know where it's increasing and decreasing. So just to review, what I did is I took the derivative, I set it equal to 0, I factored it, and I found my 3 critical numbers, 0, negative 2, and 2. I put that on a number line in order, and I found numbers in every interval before and after each of these critical numbers, and I tested different numbers. I took these different numbers and put them into my derivative to see what sign I get. Again, I don't care what number I get, all I care about is the sign. So for example, when I plugged in -3, I got a negative, and a negative, which tells me the sign negative times negative is negative. I did that for all 4 intervals, and I found out where it's decreasing, which was -∞ to -2, and 0, 2, and where it was increasing, -2, 0, and 2 to infinity. The last question that it asked was, the second question asked was find the coordinates of the extrema. Well, the coordinates are x equals 0, x equals -2, and x equals 2. Those are the coordinates. And the last question is where identify each relative extrema as a max or a min. Okay, so I'm going to look at this. Okay, I have 3 critical numbers, and I need to know are they max or a min. I'll do a different color. Let's first look at -2. At -2, I went from a negative to a positive. If I go from negative to positive, again, in case you forgot, if I go from a negative slope to a positive slope, it's a minimum, which tells me -2 is a min. 0, I go from positive to a negative. Positive, then negative means max. And the last critical number, 2, I go from negative to positive. That tells me that I also have a min. So that's how you solve these types of problems. You find the critical number. So again, you find the critical number, and I did that by taking the derivative, set it equal to 0. I factored it and solved for what numbers would make it 0. Then I took those critical numbers and put it on a number line. From that number line, I found 4 intervals, and in those 4 intervals, I found the number that I'm going to test. With those numbers I tested, I plugged it into the derivative and figured out the sign that I would get. It turned out in this interval I got negative, and positive, which to answer the first question means I have an increasing interval at -2 to 0 and 2 to infinity, and I have a decreasing interval here, -∞ to -2 and 0, 2. The second question asks what are the coordinates for the relative extrema, and again we found that already. Our coordinates are x equals -2, x equals 0, and x equals 2. And the last question said, with those numbers, -2, 0, and 2, those critical numbers, do you have a max or a min? Well, I looked at -2, and I saw I went from negative to positive. That told me that that was a min. At 0, I went positive, negative. That's a max. And at 2, I went negative to positive, which is another min. So hopefully you understand this topic. Again, it's a lot of work. I try to explain it or go as slow as I can. Let me know if you have any questions, and I'll see y'all later.